Number 7. The poisonous gas hydrogen sulfide, which is H2S, can be neutralized with a base such as sodium hydroxide, which is NaOH. The unbalanced equation for this reaction follows. A student who was asked to balance this equation wrote the following. Is this equation balanced? Is it correct? Explain why or why not, and supply the correct balanced equation if necessary. So, I'm looking at this. All right, so basically, the unbalanced equation for this reaction is this. This is the true equation right here. That's kind of like we have the answer sheet. A student who tries to interpret this reaction writes this. The question is that student right? I'm sorry, there are two questions. Is the equation balanced, and is it correct? It's yes to one, but no to the other. Here we go. It is balanced. If you count the number of sodiums on each side, it's the same number. Number of oxygens on each side, it's the same number. Number of hydrogens, same number. Number of sulfurs, same number. But here's the thing. Water is a product of an acid-base neutralization. This is not water. Okay, this is actually an ion called hydronium. Over here we got sodium hydroxide. Even if you don't want to look at your polyatomic ion sheet and see that sodium has a +1 charge, hydroxide has a -1 charge, and so having two positive ones is going to disallow you from being ionically neutral. You just look at here at this correct answer for sure and see that this is different than that. One of these things is not like the other. And so it's balanced, but not correct. And what we're doing here is we're referring to the 3 requirements for a correctly written chemical equation. And one of them is you have to have the correct formulas for the reactants and the products. Here, the student doesn't. If we were to change some subscripts, it would be correct. What are those? Water is H2O, and sodium hydroxide is actually NaOH. And that is the basis for this person's error. Now, we also want to balance it. We're going to be balancing the correct, appropriate chemical equation. And let's see. So we got 2 sodiums over there. I'll throw a 2 in front of there. So that means for hydrogens, we got 2 on that side, but we've got 2 more from here. So that's 4 hydrogens on this side. Only got 2, so I'm going to need to double that so I can get 4 hydrogens on this side. Oxygens, 2 on that side, 2 on this. Okay, that's balanced 1 on this side. Okay. All right, so we're going to go 2, 1, 1, 2 for the coefficients for this correctly written, balanced chemical equation.